Welcome to our very short lesson in physics. Last time we spoke about this bird hanging on my finger. Well, hanging and moving. We have explained why it is hanging, because it has some weights in the wings, but we haven't asked why it is moving like this. Today I have a whole collection of different animals for you. A big dog, twins dog, small dog, we have a big turtle, a middle turtle, a very small turtle, we have fish, we have this calamar, we have bugs shaking their legs, we have this bird moving his tail, we have everything shaking and moving today on my table. The question is why some of them are moving so quickly and others are slow. Well, the first question is why it is hanging and moving. Well, it's hanging, we know it quite well, because the point of hanging is just above the center of mass. And then we have a counterweight on the other side for all of them. So this is clear. They move because they are hanging in a correct way. But what about the period of their shaking? Well, one would say some of them are heavy, other are light. I will remember you two animals that we had last time. We had this bird from Berlin with counterweight, moving slowly, and then we had this grasshopper from Amsterdam, moving a little bit quicker. Well, what about the weight of these objects? We have the measure. Well, the bird is quite light and the grasshopper is heavy. But grasshopper is slower than the bird. So it's not only the mass, but also something else. What is that something else? I have two similar objects here, which have similar masses, similar metal balls. This is an owl, and this is an acrobat. The balls are quite similar, and the masses of two objects are quite similar. Now let's move the owl. It is slow, it's very slow. And the acrobat is quick. What is the difference? The difference is that the distribution of masses is different. The acrobat has masses which are close, the center of mass is close to the point of rotation. The owl has the mass at a big distance from the point of rotation. This is exactly like during skating, when the player wants to make quick rotation, brings hands close to her body. When she wants to go slowly, makes hands far from her body. So this changes the distance of the mass distribution. So the point is that the distribution of mass is important. In a what way? It is a product of a mass by a distance. No, a product of the mass by the square of the distance. This is called momentum of inertia. So momentum of inertia of this acrobat is small. Momentum of inertia of this owl is big. We can make a measurement, then I will show you a series of other funny players. Well, these are two toys for cats. I have chosen them to have similar period of vibrations, of oscillations. Well, they are not exactly the same, because these are not laboratory objects, but are objects I find in shops with toys, and here I have weights taken from the bird. The one weight will be fixed far from the center of vibration, center of rotation, we would say, and another close to that center, where the distribution of mass is different. Now, the masses are exactly the same, but the distribution of masses is different. The distance here is much bigger than here. We would expect that this pink cat is slower now than the gray cat. Start. Yes, it is quite slow. So this is the distribution of mass. We have also two cows. We can check the same with two cows. Again, chosen in a shop with similar periods of oscillations. Well, pretty similar. And the same masses, one will be fixed closer to the point of the vibration, point of rotation, and another just here. No problem, this is real physics, real experiments. We expect that this one is slower. Let's start. Yes, it is slower. The difference is not so big, but it is slower, for sure. Just to finish, some more funny objects. These objects I got in shops in Berlin. These are two lovers with different equipment. So these lovers are close. All three objects have similar masses, similar heads of these lovers. They are on swinging here with big distance of their heads from the point of rotation. Here swinging close to the point of rotation, and here somewhere intermediate. Let's start from this one, which should be quickest. Yes, it's quickest. This is a little bit slower, and this is quite slow. The lesson we learned today is the momentum of inertia. It's not only the mass, but also the distribution of masses which makes the difference. Thank you very much, and swing with your humor with these funny vibrating animals. Thank you very much.